All right, let's try out our first example. And is what we want to do here is we want to take the limit as h goes to 0 of f of x plus h minus f of x and then all over h. And so that's exactly what we're going to do. I'm going to write my equal sign over here because I have a feeling we're going to need a little more space. The limit as h goes to 0. And so you should keep writing the limit sign here until we actually use direct substitution here in a little bit. Okay. So we have the limit as h goes to 0, and now I'm going to replace x's with x plus h's. So we're going to have 4x plus h squared plus 2 times x plus h minus 5. And then we want minus f of x. So if you do minus f of x, it's just going to change all the signs up here. So we'll have minus 4x squared minus 2x plus 5. And then this is all over h. Now, if we try and use direct substitution right now, you can see that the denominator is going to be 0. So it doesn't quite work out for us. We're going to need to distribute and see if we can cancel this h down here. We want to get rid of that thing. And I think I'm going to give myself even a little bit more room. Limit as h goes to 0. And we can go ahead and distribute here. So we're going to end up with a 4x squared. Then we're going to end up with a plus 8xh plus 4h squared. So that is doing the x plus h times x plus h and times 4. And then we'll have plus 2x plus 2h minus 5 minus 4x squared minus 2x plus 5, and then all over h. I do want to do, I did skip a step, and I actually want to show it just in case anybody needs it. So this 4 times x plus h squared, I again multiplied all this at once, but if you square this x plus h, you'll get x squared plus 2xh plus h squared, okay, again by foiling. Now if you distribute that 4 through, you'll see we get the 4x squared plus 8xh and plus 4h squared. Let's see what cancels. And if we have done this correctly, we'll only be left with terms in the numerator that have h's. Okay. So for instance, this 4x squared hopefully cancels with something. Let's see. Minus 4x squared, good. And then 2x and minus 2x and minus 5 and positive 5. So let's go ahead and write down what we're left with then. So this leaves us with the limit as h goes to 0. And actually, before I write down what we're left with, notice all 3 of those terms have an h in them. I'm going to just factor that h out while we're at it. So we have 8x plus 4h plus 2. And then that's all over h. And since h divided by h is 1, this becomes the limit as h approaches 0 of 8x plus 4h plus 2. And now we can finally use direct substitution. And if we let h go to 0, this is just going to give us 8x plus 2. And you can see now that I've done the direct substitution, I dropped that limit sign. Let's go ahead and jump to part B. Find the equation of the tangent line to f of x at x equals 5. And let's see how this applies to this question. Well, we know that the equation of a line through any given point, okay, can be given by this equation here. Now, this m, our slope, we now know to just be the derivative at that point. Right? This is in place of m now. All right, well, let's start trying to fill in all this stuff. Well, we know that f prime of x is equal to 8x plus 2. That's what we just found down here, 8x plus 2. And now we want to plug in this x value that we're interested in here, this x equals 5. That's going to wind up being our slope. So if we plug in 5 there, that's going to give us 42. Pretty steep slope. The next thing that we could go and find is, well, we're going to need this y1. We need to know the x value that corresponds to x equals 5. So let's maybe write that in here. y1 equals f of 5. And so if we plug in 5 into f, that's actually 4 times 5 squared plus 2 times 5 minus 5. And that gives us 105. All right, and you may have already caught on, for x1, we've been using 5. So we have everything we need now to write the equation of this tangent line. So we have y minus 105 is equal to the slope times x minus x1, which was 5. And then we could go ahead and distribute that 42 through, and then we could add the 105. So we'll have 42x and then minus 42 times 5 plus 105, and that gives us y equals 42x minus 105. Example 2, find dg dx given g of x is equal to the square root of 3x plus 4. Now, this may sound like it's a different type of problem, but remember, this is just another notation for saying g prime of x. We're just being asked to find the derivative. So dg dx, the derivative of g with respect to x, is equal to the limit as h approaches 0 of g of x plus h minus g of x all over h. And let's go ahead and substitute in x plus h into g. So just going to replace that 3, or I'm just going to replace the x here with x plus h. So I have 3 times x plus h plus 4. Okay. And then we have minus g of x, which is just the square root of 3x plus 4. And then this is all over h. If we try and use direct substitution right now, we'll have h equals 0 in the denominator. This is going to be a common issue when we try to take the derivative. And what we're going to need to do is try and do some simplification to see if we can maybe cancel that h out that's in the denominator. And the trick here is that we are going to multiply by the conjugate. All right, so the conjugate is going to look just like this, except we're going to change the sign in the middle. So this is going to be the square root of 3 times x plus h plus 4 plus the square root of 3x plus 4. And I'll multiply by the same thing in the denominator. And when we do this, we're really just multiplying by 1. It's just a complicated looking 1. All right, next we'll FOIL. And this should work out nicely because we have a difference of squares here. So our first term is going to be the result of multiplying the square root of 3 times x plus h plus 4 times itself. So we're just going to lose the radical. So this becomes 3 times x plus h plus 4. Our two middle terms will wind up canceling from that product. And then finally, we're going to multiply minus the square root of 3x plus 4 times the square root of 3x plus 4. So it's just going to give us minus 3x plus 4. And then this is all over h times this mess down here. And we're going to just leave it as it is. But this is the square root of 3 times x plus h plus 4 plus the square root of 3x. Write that a little bit neater. There we go. Plus the square root of 3x plus 4. We can go ahead and distribute in the numerator. So we have the limit as h goes to 0. Okay. Again, I'm still writing in my limit signs because I have not made that direct substitution yet. And so this gives us 3x plus 3h plus 4 minus 3x minus 4. Okay, and you'll notice we lose the 3x's, the 4's, and all we're left with is a 3h in the numerator. So I have 3h all over h times all that stuff. All right, and you can see now the h's cancel, so we get the limit as h approaches 0 of just 1 over the square root of 3 times x plus h plus 4 plus the square root of 3x plus 4. And finally, we can do direct substitution now. So if you let h go to 0, this just becomes 1 over the square root of 3x plus 4 plus the square root. And I just realized I missed a factor of 3 up here. Let's go ahead and fill that back in. So only the h is canceled. I should have a 3 here and a 3 right here. Okay. And then here we had 3x plus 4. There we go. And one more step actually. We want to combine these two. We have 2 of them, right? So I'm just going to rewrite our denominator as 2 times the square root of 3x plus 4. Let's write that here. So 3 over the square root of 3x plus 4. And again, because we had 2 of them, we're just going to multiply that by 2. And so this right here is our final answer. And remember, that was all equal to dg dx. Took us a little bit of work to get there, but there it is.